Hello, everybody. Welcome to the ODPi webinar. Today, we're going to be discussing building a data lake with Egeria. I'm Chris Blum. I work in the marketing side here at ODPi, and I am going to hand it off to Mandy Chessell and let her take it away. Welcome, Mandy.
Thank you so much, and thank you everybody for joining. So this is a little bit of a sort of history lesson around where Egeria came from, and to give you some extra information about how Egeria is evolving to help people who are building data lakes. So I got involved with my very first data lake in 2013 in a project with ING Bank. And if you know about the Egeria project, you know that many of the community members either work for IBM or ING, and it actually stemmed from this very initial project. And at the time, Hadoop was very, very popular, and there was a lot of desire in many companies to take all the new digital data that was coming out of everything we started to do online, you know, information from our phones and the browsers and all the online shopping and sort of things like the IoT devices, our cars. There was just so much data coming out. And it wasn't traditional relational data. It was in all different forms. And so there was a great deal of enthusiasm about, you know, people felt that they would be able to understanding it closer to their customers, that they would make better uses of resources, or all those sorts of values around the data itself. So, so a lot of excitement, and then the open source world, particularly around Apache Hadoop, started to innovate with this new data, and that again created a huge amount of excitement. But the focus was really on just dealing with the data, and it started to create some issues in some organizations because data was being brought into Hadoop, and very quickly the scale of it became overwhelming, and there were often questions when it came to this data about this word, the data swamp, came up. And it was basically that as the data got so big, you imagine your own disk on your laptop, you know, after a while you forget where stuff is, and that's just you using it. But if you've got a whole organization creating data in the data lake and running their own experiments, what tends to happen is people copy the data, run an experiment, and then leave it there. And so the data lake just grows and grows and grows. And this data might be information about people, financial situations, you know, sort of stuff that really shouldn't just be left lying around. And that's what we would call a swamp. And so there was a lot of questions around how do you build trust in all of this data and the ecosystems around it. You know, and this could, and the real purpose is to make that data reusable rather than everybody taking their own copy and then leaving this this trail of data. And so the project I was on, as I say, this joint IBM ING project, was really to start answering these questions about trust and quality and safety all around these types of systems. And in addition to this project, I was working with other organizations, and what we started to see was what I call the data lake anti-patterns in different organizations. And these ultimately, you know, a couple of years down the line, actually described things that really didn't work. So there were organizations where they set up a new Hadoop team, and the data warehouse team that was existing in the company competed, right? And they grabbed every project, irrespective of whether it was suitable for the platform. And they literally were constantly at each other's throats rather than collaborating. The next one is, my data warehouse is expensive, let's put in Hadoop and re-implement the data warehouse as is on Hadoop. So you've got exactly the same capability on a different platform. So that really, of course, Hadoop is not designed to perform at the same rate that a dedicated data warehouse platform can. And so you had the same thing on a slower platform. The next one is the Roach Motel. So this is where the data lake is. There's a big focus on loading all the data in, and no thought about where the business value comes from, where the data is distributed to, how how anything comes out. So I call that the Roach Motel. The next one is the swamp. We talked a little bit about that. And then finally, I call it the artisans. And this is where there's a group of very dedicated developers hand coding all of the data provisioning into the lake, through the lake and all the different processes, and then out the other side. And this works for a little while, but it doesn't scale to an enterprise because this provisioning is highly volatile. You think it's, you just do it once, but actually things change continuously, like source systems change their structure and stuff like that. So what happens, no matter how hard these teams work, without tools to help them with the data provisioning, they are always behind, and the team gets a reputation for being, not serving the business. So that's typically what, and they end up losing funding and things. So given those things, those things that have gone on, is it possible to be successful? Yes, it is. But you just have to be mindful of the things that can go wrong. And generally when things go wrong, it's all about you either lose business agility or the cost just starts to escalate. And it's because in most businesses, they operate in functional silos, and data flows laterally between them. So all the normal command and control approaches don't work. And organizations, silos within it, are used to sort of gathering all the resources they need and operating independently. So you end up with each part of the business trying to hold all the data, their data and everyone else's. And it's how do you change the culture to allow that lateral lateral exchange of data. Now, it's not just culture. There is a technology side to this. There is an enablement of this data lake environment. And that's really where this data lake architecture came from. And it was jointly developed with ING, but then verified and extended. So the version that ING uses simpler than this, and the rest of this has been added to by visiting over 100 other organizations and working with them on their requirements. And it was a very use case driven, performance driven, sort of looking very much about the non-functional requirements to create it. The architecture's very componentized so that different pieces operate independently. They can be scaled up, scaled down, and nobody puts this whole thing in at once. So there are different roadmaps for supporting it. And what I'm going to do today is show you different parts of this architecture. You're not expected to sort of remember this particular picture. It's there for reference, but I'll talk about different capabilities, why they are like they are, and then show where Egeria is fitting in, because effectively what happened was that the structure seemed to be good, but many organizations found this difficult to implement because the technology wasn't integrated, and it wasn't integrated in a way that it could exchange knowledge. So you ended up having to configure each technology separately and maintain that configuration, and that became very expensive. And that's really where Egeria came from. So I'm going to let's start with looking at the high level green boxes. So if you look at this picture carefully, you'll see that there are lots of little boxes, but there are some bigger boxes. These are the subsystems of the data lake. And this next picture just takes those subsystems and takes all the small detail off and sort of gives you a high level view. So each of these major subsystems are, are providing key aspect to the data lake. So one of the things that we're trying to support is the fact that analytics, AI models and things, they're not something that runs at the end of a long pipeline of data to produce a historical answer. They need to be pushed into the operation of the business. So they need to be pushed back to the sources and the systems. So we've got systems of record. This is the systems that run all the transactions. So this is how the organization makes good on their promises. This is where the money exchanges and things like that. The systems of engagement are things like the mobile apps. So they're all about the individual customer, the individual employee, the person who they're engaging with. Sources can come from the external world that's now digital. Systems of automation are sort of IoT-oriented systems. So like your car would be an example of a system of automation, where it's gathering information either about a location or a particular, I'll use the word device. And so it's very focused on an asset or a location. But there's information about people running through this, there's information about the business and transactions and the services offered by the organization, but the data is structured differently in each of these systems to focus on its major subjects. So, you know, systems of record, the transaction, system of engagement, the person, systems of automation, the asset or the location. And so they all connect into the data lake, and the data lake is sort of taking data from all these places, and there are many different processes running to actually come and create different types of insight for different types of business problem. So we need to be able to deploy the analytics. So this is a production environment, but because the data is so big, it also has to be the development environment for the analytics teams. And so you see at the top of the picture, there's this self-service access. So this is allowing the data scientists to find data, to run their experiments, to create results, either that the results are shared or the model is captured, pushed into a DevOps pipeline and deployed either in the data lake repositories or out in the original sources. So, so as I say, this is an environment that is both production and development, and that self-service access is all about protecting the production repositories, but allowing the flexibility for the data scientists. So that's the bit at the top. And of course, the analytics engines also need to access to the repositories. And the catalog is where all of the users find data, but it's also where the setup of the governance around the data. So what is its classification, who owns it, information about how it's being updated and how it's allowed to be used, so its terms and conditions, that type of thing. And then the governance team basically take that information and define policies for each of the different types of classification of data that's in there. And there's also an interface that the business use, and it looks very similar to the one that the data scientists use, but it's seeing a very different subset of the data lake. So simple, basically squares of data that fit in spreadsheets would be the simplest way of thinking about the difference. Whereas the data scientists, the analytics team, they need to see data in its raw form, how it's stored, how it's operating. So they see much more complex, messier data than the data that the business teams see. But the function is the same. You know, search for data. I want to see customer information for the southwest of the United States, for example, would be an example of the sort of thing that they might be looking for, but they would get a different list of data sets for the two groups. And then we mustn't forget the data lake operations team, because they actually have to run this complex environment. And one of the reasons it's complex is that all of the different workloads is very high variety in the type of data. There's also high variety in the type of data platforms that are needed to run the workloads and the structure of the data. So the data lake is inevitably multiple data platforms, multiple engines, moving and combining and analyzing the data in the sort of runtime environment within the data lake repositories. And that's what makes it complex, because there are so many so many different types of technologies that need to be brought together as a single solution. I think there's a question. Okay, because so someone said they can't hear. Can everybody else hear?
Yeah, I can hear. This is correct.
Okay, all right. So I'll keep going, and hopefully, hopefully the problem will be sorted. Okay, so let's just move on to this next picture. So I just wanted to characterize the difference, and I think today most people have got this in their head, but initially there was, you know, people thought, oh, it's just one is using Hadoop and the other's using a relational database, but it's not that. It's that the data lake is a hub. It's a combination of many different types of technologies. It's designed to cover both that development environment and the production environment, and is all around real-time analytics. The data warehouse actually sits inside the data lake, because there are still very valuable use cases for data warehouses. They don't go away. They just become part of this bigger ecosystem that's able to handle a greater variety of data and platforms that are not possible within the warehouse. So, and this is what I call the washing machine picture. This is really another picture of the data lake, showing the fact that it's a very active, dynamic environment, and data is coming in and going out. So it's a hub and reaching many different types of systems. It's not, data isn't just coming in, it's also being distributed out of the data lake. And at a very high level, sort of, what are people doing? So people who have data can advertise it in the catalog. So the catalog contains information about all the data sets in the data lake and how they're governed, but it also catalogs the downstream data that could be available or that has already been copied into the data lake, because we need to know the downstream information to be able to do lineage. So this catalog is, as I say, not just the data in the data lake, it's the enterprise's data with documentation of all the feeds. So initially you might just advertise, hey, there's this new customer database that's been added as part of this new marketing initiative or whatever. Then a number of things could happen. Someone could find that that catalog entry and say, oh, I want it. And so the data could be provisioned into the data lake, so it can then be made available to the data scientists. So the provisioning could happen before or after it's discovered. The other thing that could happen is that this could be a person finding it, but it also could be a discovery process that is augmenting what is known about the catalog at the same time. So that's the discover. And then a data scientist or a business person comes along and says, oh, I want to look at the data. And what happens is when they ask for the data, because this is a production environment, you don't just give people access to production data. A sandbox is created, and either a subset or a redacted version, or the whole thing is copied in, depending on the policy associated with the data and its sensitivity and who the person is and what they're trying to do will determine that copy. And we always create a copy, whether it's in memory or on disk, because most exploration processes transform the data to get it into a format that's suitable for analysis. And of course, again, you can't do that on production data, because all the processes that expect the data in a particular format would then fail. So that's the other reason why we use sandboxes. And then, ta-da, we've got a new model, and then we go into a deployment process, which is really a feed into the DevOps process, because that model doesn't run on its own. It needs to be hosted, it needs to be callable, it needs to be able to distribute its results. So it is actually a service. So we need a data engineer to take that model and embed it in a service and make sure that it's got the right data coming in and out of it that matches the vision of the data scientist. So that's that deployment stage that's requiring, that completes the process. And I've got the arrows. The blue arrows are roughly data and metadata. The white arrows are analytic models. If you see that on the charts and wondered why they're different colors, that's roughly what it is. And the arrow's going off to the side because it might be deployed into a different environment. The other thing that data lakes do is act as a distribution hub. So, you know, raw data can be coming in, some wonderful processing can happen, and then the output could be distributed to different systems. And particularly when, say, for example, you were doing scoring on customers, excuse me, or products, then maybe those scores would be distributed for the mobile app, for example, would be an example. All right. So the other thing that we were learning as we went through is that there are a set of unique capabilities that need to be associated with the data lake. And at the time, so this particular picture came from a blog post, and I'll put the URL on the side here. But one thing you'll notice is that it was called the data reservoir, because at the time, data lake meant Hadoop. And we were trying to say, well, wait a minute, it is Hadoop, but it's also the warehouse and analytic, you know, sort of specialist analytic boxes and things like that. It's a combination. It's not just Hadoop. So we use the term data reservoir, but then over time, the term data lake has then been has started to take on all these extra capabilities, and so people pretty much accept that you have to have a catalog with a data lake, and that governance is important, and there's multiple platforms, because that's actually what everybody's experience has been. You try and run everything on Hadoop and you hit performance problems. In fact, it's true of any platform. The data warehouse has exactly the same problem. If the data and the workload don't match the data platform, you have performance problems. So that's why the name was changed. And you can see here from the different types of capability that, as I say, the catalog is there. We've got multiple repositories. The repositories are protected because they're production repositories, and just like in your system of record, you don't give people access, so that's the protected bit. The hub is number 4. Curation is the ability to advertise and add extra things around the catalog description, and this was something that really wasn't very available. The idea that the business needs to be in control, that has been in the theory of data governance forever, but very hard to achieve because the business needs to be able to change values that then immediately affect the runtime. So in the data lake architecture, we were suggesting that these values, from the metadata values, are pushed down and interpreted by the engines at runtime and used to control what happens in the lake. And that means the business, when they change a value, changes the behavior in the data lake. So that's number 6. Number 7, obviously there's a lot of monitoring, auditing that's part of this design, because this is a very valuable system. Number 8, where's that gone? Can't find number 8. Oh, there, it's data-centric security. So when ultimately inside the data lake, there are many copies of the same data, because it goes on to different platforms to support different workloads. And the data lake manages those copies, so they're not a problem in themselves, but it means that traditional resource-based security like access control lists don't really work, because there's a risk that the access control list will not be consistent on each platform. So you need a security that's actually this dark ring is actually a security layer. There's in fact 2 security layers. There's the blue ring, the outer edge of the data lake, which is basically saying, is this user, is the system even going to come in? And then that inner protection says that only processes that run, that are part of the data lake can actually run and access anything inside the data lake repository. So the green services can access it, and any engines that are inside managing and shifting data around inside, and nothing else ever gets inside that central box. And that just simplifies the security problem to a securing the services to people, and the security is modified not just with who they are, what they do, but what's the scope of data they are looking for. And then the inner stuff, which is the real engines that are working, they're sort of a different group, different security group altogether. And then number 9 is just the difference between the two types of self-service access. Functionally the same, completely different data is returned. So those are the sort of things that were coming out of the data lake work. And even with all this work, and we actually went down and each component within that complex picture was described in detail, exactly how to code it, how to set it up. It was still an awful lot of work. And fundamentally, it was hard because there was no integrated metadata. And it was very obvious, particularly when you had cataloging for sort of curation and searching and finding things, and cataloging to drive the engines, that a single metadata repository was never going to work, because the performance characteristics of the thing that was being used operationally is very different from a sort of catalog search, which is also very different from the sort of maintenance of metadata type environment that you need around the curation. And then also so many products have worked out that metadata is good, and they all have their own repository. So none of them are going to rip that out and go for a central one. And this is why we have this peer-to-peer view in Egeria. And this book laid out, it's a pamphlet really, it's not a book, laid out the reasons for Egeria. And the only thing that's wrong with it is that at the time we were going to put all this function into Apache Atlas, but it proved to be just too big, and it was a project in its own right. We were new to open source, hadn't realized that. But as I say, we had a lot of help from the sort of more experienced open source people, both in the Apache Atlas community and in the ODPi and Linux Foundation. And they said, no, you're a separate project, and this was the forming of Egeria. And if you watch, and if you've been watching us for a while, you'll know that this month is our 2nd birthday. And so we have done an awful lot in 2 years. So let's have a look at what we've done. So what I'm going to do is, what I've done is I've taken that original data lake architecture and pulled out different fragments to talk, so that we can talk about something that's consumable in different steps. So for example, the first bit is, let's talk about how we do that advertise and provisioning. How do we bring data in and out of the data lake? So we're going to cover that. Then we're going to look at that ad hoc self-service piece. So how is data discovered, located, extracted, and accessed? We're going to talk about that. Then we're going to do a little bit about the role of the data scientist and how they work. So it's a sort of an extension. It's almost like the data scientist is a specialist information user. Then the next step is we're going to look at the data movement from repository to repository. So this is not, dump all your data and everybody works off the raw data. It comes in raw, but then there's lots and lots of processes that refine. And so data is being, new data is being created. And if you're an information architect, you mean, oh, wait a minute, if new data is coming from here, this thing needs backing up and archiving and all sorts of things. So the fact that we generate new data in the data lake means that it becomes something that needs disaster recovery and archiving and backup. And so how do we manage that? And then we've got the automated maintenance. So this is very related to the first bit, which is how do you handle the fact that data needs to be actively managed. Then we're going to talk a little bit about the governance team, and finally our operations team that need to keep this stuff running. Okay, just checking the comments. All right, so let's start from the outside. And this is the original picture, but I've pasted over all the internals. And this is what we call the system context diagram. So this shows all the stuff that's outside of the data lake and the types of requests that are coming in. And when you get your coloring pencil out and say, well, where is Egeria? The bits that I've colored in blue are the services that Egeria provides directly to the data lake. So when we bring in Egeria, that corner of the data lake is supported by Egeria directly. And then the green, which is everything else pretty much, is where Egeria has, the open metadata from Egeria has been pushed to different technologies to support things like sort of controlling access and scope and the processing that's going on. So it has a, open metadata itself is almost everything that's, that's driving what's going on. And then Egeria itself adds particular interfaces that are called by groups of people, generally people, because it's meant these new roles around governance and curation that really are not served very well, not in a generic way that's needed for something the size of a data lake. So that's really one of the reasons why Egeria is looking at the access services, the view services and the UI is actually for that corner of the data lake. Okay, so that's sort of from the outside, and where does Egeria show? And then I mentioned the word access server. So these are the specialist interfaces that sit in the metadata server, in Egeria metadata server, and provide services. So that when we talk about services, I mean APIs and events in and out to the different types of technology that are sitting in the data lake. And the bit in the middle just shows the scope of metadata that Egeria is covering. And you've probably seen this picture many times, but I just bring it up so that you're familiar with the name and what it is. So this is specialist interfaces on the metadata repository. And the other thing is that everything has both an API and an event driven. So irrespective of where those access services are located, when something happens, like somebody adds a new database to the data lake, then events are fired to appropriate OMASSs. And so different users are informed when something changes. And so it's like, you imagine it's like a ball bearing sort of pinging all over this the pinball machine. And that's basically, so when something happens, lots of other things are triggered as a result. And so that's how we make it a very dynamic environment. And so a lot of the activity in the data lake is actually driven from the events pinging off of one another when things happen. And that eventing we've been talking about is, see in the center, this cohort topic, that's sort of it's connecting the metadata repositories together. And so that eventing I've been talking about is running in that cohort, in that central ring. And so it means that when metadata repositories connect, they're involved, they're bringing metadata in and learning about new metadata. We'll ignore the conformance test server, and then the metadata access point is just the OMASS is deployed without a metadata repository. If we add a metadata repository, it's called a metadata server. So they're pretty much the same thing from the outside. It's just whether it will store metadata itself. And so that's how that event bit comes in. And then I talked a bit about the view server. This is supporting the specialist REST APIs for a UI. And so that's really where the presentation server and the browser comes in. But this is for that corner where Egeria is supporting a whole series of different types of business users. That's really what that view server bit is. And then the governance server is for integrating with third-party technology that doesn't support Egeria directly. So it's acting like the Babelfish, translating metadata, open metadata to specialist metadata for the particular technology. And so that's how we actively manage the third-party technology. And the purpose of Egeria is really about managing the complexity of this environment and doing the first 99 miles, so that when you're deploying a data lake, you're only doing the last mile. So you're doing the connector that actually does the translation between your specific type of third-party technology and Egeria. And over time, the out-of-the-box connectors will increase, and so the last miles that you need to code will decrease over time as we begin to cover the most popular third-party technologies. Right, so let's start digging into the actual Egeria implementation. So we're going to start with data coming in and out and the sort of basic description curation of metadata, of data and metadata basically. And one of the things you'll notice is that there's a lot of automation. So there's a lot of stuff coming from the enterprise IT systems, all the different types of systems, and data flowing in both directions through ETLs and data feeds and APIs and standard events like Kafka events and things. So all the different types of data integration that we've invented are all relevant for the data lake, because the data lake needs to offer the service that matches the thing it's integrating with. So, which is why you end up with all of the different types of integrations. And then we have the API, the catalog interface, which is something that Egeria provides. But also there is data coming in. You see this information user is doing a data deposit. You imagine a data scientist does some work, runs a model, and comes up with an amazing spreadsheet of results, and they want to share it. So that's the data deposit. And when you look at the repositories, I'll show you in a little while, you'll see there's a whole series of repositories that are people's personal data stores that they then manage through the APIs. So we've got company data and data from external parties, as well as the personal files and outputs that individuals who are working with the data lake can store. And we provide that storage to stop that data going off somewhere else. So by making it easy for people to store new data in the data lake, it means we keep control of it. It's catalogued and it's not on a memory stick somewhere being passed around by email. So that's the reason for doing that. So let's look at that from an Egeria point of view. So what you'll see, so the integration daemons and the discovery servers are those governance services. And then the metadata server, or it could be a metadata access point, has a number of OMASs deployed, and they are providing those interfaces. So for example, the ability to detect new files being put into the sort of inbox of the data lake is the data manager, or the one that's monitoring database servers to detect new databases and schemas coming through. That's the data manager. The data engine is providing APIs for the sort of data provisioning type tools like ETL engines to log lineage. So this is my process, this is the structure, this is where I take things from, this is where I put it, and whenever it runs, this is my latest log file. So that's the data engine. And either the data provisioning engine calls the data engine OMASS directly, or there's an integration daemon that's translating from the lineage that engine provides in its own repository and brings it into the open metadata world. And then finally, discovery is a set of automated processes that look at the new asset. So either the data manager say the data manager's produced, so hey, there's a new database that's been added. The discovery service would then look at it and profile that data, provide additional information about what's in the columns within the tables in this new database, that type of thing. That's the discovery server there. And it talks to the discovery engine OMASS. And then finally, manual curation is through the asset owner, whether that is sort of system files coming in a sort of ad hoc way, or people storing their own personal files. That's both done through the asset owner. So that's how Egeria supports data onboarding. Let's go on to the next one. So let's talk about the users doing their self-service access. And you're going to see a very similar pattern, but just different names, different interfaces, because what we did originally when we did the first sort of, this is what Egeria looks like, was actually work through the architecture of the data lake and say, well, okay, we're going to need to integrate with this type of technology. That means we need one of these OMASs. And it was how we identified that initial list that you see in our charts before we'd written them all. So, we have a stewardship server, not implemented, but certainly there's a skeleton of it that will be the place that has what we call governance actions, which will provision sandboxes on request. So when people find things in the catalog and they go, oh, I want a copy of that, click provision, and that will call out to the provisioning engine. And again, the reason it's a plugin like that is that different organizations will have different provisioning engines. However, whatever that technology is, somehow that provisioning needs to log to the data engine that there's the lineage of the transfer of data from one of the data lake repositories into the sandbox. Because sandboxes need cataloging, they need governing just as much as everything else. The security sync server, here, this is actually configuring security. So we have a working demonstration showing the governance engine OMASS publishing to the security sync server changes to classifications on, for example, data schema, sort of a column. So this database column was public, now it's confidential. And that would then, the security sync server has a connector that will push to Ranger, for example, and would call the Ranger interface to make changes to the way that the security service is set up that's being used to provide something or other. So here I'm showing it connecting to the search service. So this is a search service that is searching documents within the data lake. So the catalog will tell you what type of assets are stored. The search service is looking inside documents to show you which documents have the phrase, ODPi Egeria second birthday or something. So there's a difference between the two services. What else? I think I've covered most of that. So that's really supporting that end user interaction and building, and acquiring the data that they need to do the work that they're doing. The other thing that's recently happened is that, of course, it's not just people that need data. And if you've been watching, there's been a new OMASS went in recently that supports tools that build analytic models and reports and those type of things. And I'm sure that over time we'll start to see more specialist OMASs. Yes, which is one way to go. The other is that the asset catalog and asset consumer provide a general interface for applications to access information about the data in the data lake. And then OCF connectors, so that's open connector framework connectors, can be used inside applications to connect to data APIs effectively that are public to the data lake, and to see the catalog entry for that particular data at the same time. So there are different ways of integrating applications into this environment. Okay, so we got the data scientist, and so assuming that they've created their sandbox, what do they do next? And this is a very high-level view of the data scientists work in an incredibly iterative way. So they find data, they look at it, oh no, that's not quite right, let's find some more, look at it, find some more. And then after many, many experiments, then the model goes into the deployment phase, and then the data engineer starts to work out, you know, how can I get this data, how can I make it work? And then the results of the running model in production then feeds back, provides more data for the data scientists, and the model is improved. So it is a loop. And behind the scenes, the data science OMASS is gathering information about the models that the data scientist is building, particularly around the type of data that's needed to make that model behave correctly, and the type of results that are produced and how they can be used. So it's really tying the input and output of the model together. So that's the data science OMASS, and then the DevOps OMASS really is about managing the metadata related to deployment. So basically what platforms have been changed, what's the component status on the platforms that are running through and operating within the data lake. Repository to repository, just looking at the time, so I'm going to go a little bit faster. There are many types of repositories, and so this is just a selection of the different types of things you could have in the data lake, and you can see the warehouse sitting in the middle there. Some of the data is raw data, so the historical data is pretty much raw data coming in. And then think of this as a sort of waterfall coming down the page, in that raw data is then transformed into various different ways. And ultimately at the bottom, you've got new data that can be published. And this is the data that's typically made available to the business users, whereas the stuff at the top is the data that's being used by the data scientists. And this context data is really keeping track of all the things that are used for linking. So the asset hub would be things like customers and products and things like that that are necessary to both validate data and to link it together. Again, the most important thing when we've got all this processing going on is that the data engine OMASS is being called as data is being moved and transformed, so that we have full lineage of how the data got to the data lake, but also then what happened to it once it was in, and how are all of these different repositories populated. Where are we now? Automatic maintenance. Now, we've done a number of webinars on the governance zones, and they come up quite a lot in cataloging and things. And basically, an asset can have a list of zones that it belongs to. And the zones themselves, through the governance program OMASS, can be linked to different types of policies. And so you can have maintenance programs. So you could have, for example, a trash can zone. And when people are finished with their files, they can go into they can be assigned to the trash can zone. They cease to be visible to most people in the catalogue. And then an archiver could come along and look at the type of asset, look at the retention policy associated with it, and then dispose of it as appropriate. And it wouldn't have to be sort of pass information about the assets, it would just scan the assets within the zone it's been allocated to. So that's an example of how the zoning of assets and the availability of the metadata at runtime allows simplified automation of many of the maintenance capabilities that are needed in the data lake. Governance, the governance team, there are many different governance teams, and they all are interested to be, you know, you've got people who care about privacy, people who care about risk, people who care about data governance, people who care about IT infrastructure governance, people who care about security. These are all governance people, and they need an interface to be able to look at what the assets are, but also to define the rules associated with them. And so that's what that box is all about. And really, over and above the asset piece, the governance program allows these different governance people to define their governance program. And then there's some specialist APIs called from the security officer OMASS for the operational security management within the data lake. And finally, our infrastructure team. This is really back to the deployment and how you keep the metadata catalog up to date, not just of the data assets that are coming in, but the infrastructure that's supporting those different repositories and the storage for those repositories. Because we need to know where things are to be able to do data sovereignty, or the capacity to make sure that there's enough disk space, simple things. And that's really what the IT infrastructure OMASS is doing. That's missing OMASS there, but that's IT infrastructure OMASS. And then the DevOps OMASS is about managing the change and updating of the underlying infrastructure components, linking up to the sort of data assets that you think of in the data lake. And if the pictures I've been showing on the data lake, you imagine it's a cake and you're looking down on the top. If you then cut a slice through it, the data lake itself has layers. And so the IT infrastructure is describing the actual technology that's running the data lake. And then a lot of what the DevOps is doing on top is describing the components that have been deployed to each of these runtimes. And then on top of that are the sort of the assets that the end users really care about, which is the data reviews and actual data sets and things like that, and the catalog itself. And so the different OMASs handle these different layers that different people care about. That's it, would you believe? How are we doing? We've got 5 minutes. So, so basically there's a question on the recording. Yes, it's being recorded and we will make that available the moment we have it. It takes a little while for Zoom to make that available. So any questions? I think I'm on questions. Yes. And while you think about the questions, I'll let you know that at the end of the deck, we'll also make this available, are other pictures from the data lake architecture that you're welcome to look at. There's links to more information as well. So just to let you know that there's additional information beyond what I presented today. So
thanks, Mandy. I will get the slides up to our SlideShare account today, and then we'll get the video up to YouTube as soon as it's ready. That takes a little bit longer.
Fantastic, thank you. So any questions, anyone? I know there was an awful lot there and an awful lot to take in. So if you then review this later on and you're interested in asking any questions, please come onto our Slack channel, and the various members of the community will be able to answer your questions. As I say, there's plenty of people in the Egeria community that actually know what I presented, know this content very well. Okay, well, it looks like there are no questions. Oh, wait a minute. What are the, oh, that's a good question. What are the upcoming features in Egeria for this year? The central bit, the repository services, are pretty solid. We are looking at making it run faster, that type of thing. So we're sort of polishing the nose cone on that. The next layer out are the OMASs, and we have about half of them implemented. So you'll see new OMASs coming out, typically paired with a governance server. So we've got work on a sort of common infrastructure for the governance server, and new connectors for the different types of technology that we want to connect to. So that's a real focus for us around that. There is some work going on around lineage and handling that generic lineage capability. I mean, there's nothing else that tries to provide a common lineage service. And so there's work on not just the capturing of that information, but also the visualization. And then the other piece is the user interface that handles that corner of the people corner of the data lake, which is around the asset owner, the cataloging, the searching, the kicking off of the provisioning, and all the other stewardship stuff that's going to come out as we start running to quality and things. So I often think of Egeria as an onion, and we're starting in the center, which is the OMASS and the cohort, and we're just expanding out to incorporate more and more technologies.
Awesome. Okay, well, any other questions? I don't see any coming in. We will be doing another webcast in July covering all about graphs, so keep an eye out for the email invite for that coming soon. And Mandy, thank you so much for this super informative presentation.
You're welcome. Thank you all for joining.
Thank you, everybody. And this will be up on YouTube shortly. And if you have any questions, feel free to reach out to us on Slack. Have a great rest of your day. Thank you.